Well, hello guys, here Mr. G with another video. This time we're going to be solving another question on the electric circuit for grade 12. Get a paper and pen because this one is a little bit complicated. This question is from a challenge informal test developed by professor and is a little bit difficult. This question says in a circuit diagram below, the resistance of the conductor and the ammeter are negligible. The EMF of the battery is 12 volts and the internal resistance is 0.5 ohm. The switch S is closed. Here you can see the circuit, guys. This circuit is a nightmare. It is a little bit difficult to understand. So in order for us to understand, we are going to redraw it real small and maybe easier to understand here on the side on the same circuit. Okay, so we're going to redraw it in such a way that we more or less get an idea. So let's start by saying that we have an ammeter. That is the ammeter that we have there, that is A1 here. So we're going to follow there. There at this point there is a starting a parallel connection, let's say. So we're going to do it like this, but we're going to do it straight. Okay, so here we have a parallel connection. We're going to do it in this way. At the bottom we have a resistor of 15 ohms. Okay, and then on top we have a resistor that is 10 ohm. So far so good. Okay, hope you're following what I'm saying here. This is 10 ohm, this is R2, this one is R1. Okay, now the one top, we follow the current, here we one at the bottom now. The one top, get again and get another parallel connection. The one top, I'm going to draw a small line and then I'm going to open here for parallel. Sorry there, let's fix that line there and then open another parallel there. So there is the one on top. This one have two paths, up and straight. We're going to do that one. In the straight one we go to have resistor 3, okay, and the one on top we forget about the voltmeter for now, and the one on top we're going to draw the resistor. The voltmeter is not a big problem. The problem is to know how the resistors are connected. So here, there we go, and this one is R4 and it's also 10. I'm not going to write the 10 because those are 10, all of them are 10. And now this here is a voltmeter that is going from resistor 4 to resistor 3. Okay, so this voltmeter is going here in this way from 4 to 3, as you can see, 4 to the end of 3. Okay, but also there at the end of 3 is coming the one of 15. So all this here is coming this one straight. There we go. This one is coming there. So this is more or less, guys, the difficult part of the circuit. Let's move it a little bit here. There we go. There we go. So this is what is happening there. I think it's much easier now to understand what is going on here. So now I'm going to go there and then here is the battery. But the battery is not a big problem because they are all the same. I mean the same way of connection in this case. This is V1. There we go. And this one is V2. So this is more or less the circuit. Now we got a better view. How is the connection? You can see there now. Let's still revise something. This voltmeter, which is voltmeter 2 is measuring the potential difference for this little parallel part. So if we look at this carefully, guys, it is not that difficult anymore. So what do we have? We have resistor 2 that is in parallel with resistor 1, but resistor 2 is in series with this parallel resistor 4 and resistor 3, and resistor 1 is in parallel actually with everything top, not only with resistor 2. So let's see. Now the question is not that bad. Let's calculate the reading of the ammeter A1. Now A1 is reading the total current. A1 is reading the total current. We have the internal resistance, we have the EMF of the battery. So far, the problem here is the total resistance or the total external resistance. But if you look at this one, it's not so bad. So first of all, And let's do it really slow. Let's calculate this parallel connection there. That parallel. Let's calculate this RP there. Okay? So let's calculate that one. And we have 1 over R4 plus 1 over R5. And that is equal to 1 divided by 10 plus 1 divided by 10. Okay, I'm doing it quite slow, guys. This one is equal to 1/3. So when you calculate that one is 1/3. And then if you calculate RP, remember, this RP is equal to 1/3 to the minus 1, guys. So RP is equal to 5. This one is very simple, okay? Very, very simple. So we already know that this little part here is 5 ohms. Okay. So now we're going to calculate this series part here. That part there. And we're going to do it here. It's very simple. That RS there. Okay. And that RS here, RS is equal to 10 ohm, which is this one, plus the parallel we just calculated, which is 5 ohm. Therefore, that one is 15 ohm. Okay, there we go. And now, finally, we are going to calculate the whole external resistance, which is in actual part all this parallel part there while I'm drawing with blue. That's why I say you get a pen so you can write and do the same as I do. So when you start the question, all you have to do is to stop the video, draw the circuit, and start answering the question. So all that is in parallel. Now that this is in parallel with the other 15, so we're going to calculate the total external resistance, which is that one there. Okay, I'm going to do it here at the bottom. It's enough space. The term is R total external. Okay, so that one is in parallel. It's going to be R external total, which is equal to 1 divided by 15 plus 1 divided by 15. This is not even needed, but let's do it. Let's do it like this because it's better. This is equal to 2 over 15, and then when you get the final answer, R external, I'm going to do it here, R external, which is the R parallel there, is 2 over 15. This is 2, let's fix it there, 2 over 15 to the minus 1, it is 7,5 ohm. That is the total external resistance. Remember, this is not the question. The question is just to calculate current. But to calculate current, we need the total external resistance there. So now that we have that one, we can calculate the current. So what question are we going to use for that one? Please note, all this one is question 2.1.1. All this we're doing is from one question. Please remember, this is a challenge question. So what we're going to do now, EMF is equal to current that multiply the total external resistance plus the internal resistance. We do have those. What is the EMF? 12 volt. What is the current? We are going to look for the current now. What is the total external resistance? 7,5. What is the internal resistance? Is given to us and is 0,5 ohm. There we go. So this is 12 equal to current multiplied by 8. When you substitute, when you rearrange, it is equal to 12 divided by 8. And the current is 1,5 amperes. This is the final part of the question. There we go, guys. Here we are done. All this is for question 2.1.1. Calculate the power dissipated in the 15 ohm resistor. So to calculate the power here at this point, so the power is being asked to calculate at this point. Okay, so now to calculate the power, we need either the potential difference or the current or any other data we don't have. The only thing we have is the resistance, and we have the total current of the circuit. But now let's have a look. Let's go back to the circuit, which is a little bit tricky because is that we have that at the bottom the resistance is 15 ohm, and we have that at the top all that parallel connection on top, which is parallel and series, all this part is also 15 ohm, guys. All that is also 15 ohms there. Okay, it means that the current, when it goes to this point here, the current here is going to split equally because the resistance are equally. So that is important. At this point here, the current split equally, and that is what we are going to do right now to get some marks here. So at this point here, the total current, I'm going to write it here. This is question 2.1.2, no 8, with the 8 coming from. So the current, the total current is going to be equal to current, let's say, that passes through the 15 ohm plus the current that passes through the other part. So I'm going to write a resistance in parallel 1, for instance. Okay, so now if this one is, these two are equal, okay, this is like current total is equal to 2 times the current that passed through the 15 ohm. I'm going to go back so you understand once more. Current come here and split in 2 parts at this point, guys. It's going, part of it is going down and part of it is going straight. Okay, the resistance down is 15 ohm. You can see it there. But all the resistance top, all this one here, is also going to be 15 ohm. We did calculate it there. There we calculated. This one is this part there. So that one is 15. That is why the current split equally. Okay, so if the total current was 1,5, then the current that goes through the 15 ohm is equal to 1,5 divided by 2, which is 0,75 amperes. Having this one, we can then calculate the power. Okay, so power is equal to current square multiplied by resistance. The current is 0,75 square multiplied by 15. And when you calculate that one, you get that the power is equal to 8,44 watt. Guys, I am going quite slow. All right, but that's why I say you stop the video and you rewind back and you try to do everything. Try to do this question is really complicated, and you can see it's already a mess here in the screen. Okay, now they asked for the reading of the voltmeter. Now the voltmeter, we go back to our first case here. Now what I'm going to do is I'm going to erase this one. What you can do is to redraw the circuit. Okay, so now we're looking for the voltmeter. Now that voltmeter is measuring the potential difference. Let's erase this a little bit here, guys, so we can see. No, I cannot do that because then everything is going to be erased there. So let me see, very careful. I erase this green, this one, that one there we go. So now here and that blue, so it's a little bit more clean. But you guys don't do that, just redraw it. Don't be in a hurry, you study. So now what we're going to do, this voltmeter there is measuring the potential difference for all these little parallel part. Okay, that is what that voltmeter is actually reading here, and we did calculate that part already. Okay, we have the resistance for that little part. Now the same as we just spoke here, this is 10 ohm and this one is also 10 ohm. So the current that come here is going to split equally, little bit that side and the other little bit that side there. So we need to know that. Okay, so the current is going to split there. What was the current that is coming there? 0,75 that we did just calculated. So 0,75 is going to be divided in 2 parts. Do you understand? I hope you understand this one. It's not a problem. You can write a comment if it's a problem and I will re-explain there. So if we do that, now we have the current split equally as we said, but we also have the current throughout the whole parallel part, which is calculated, and that is 0,75 amperes. Okay, so now If we do that, we can go, let's go and answer the question here at this point there. We have question 2.2.3. So what we have? We have the current through that parallel part, which is 0.75 amperes. We have the resistance in that parallel part, which is, we did calculate it 5 ohm. 5 ohm. We're looking for the potential difference. Remember that voltmeter is measuring the potential difference of R4, R3, and also for the whole parallel part. So we're looking for that parallel potential difference. Guys, if we use the formula, resistance is equal to potential difference divided by current, and we substitute, we have that this 5 equal to V divided by 0.75. Potential difference is then equal to 3.75. There are other options to solve this one, but this one is the one I see maybe better. But you can also use it for individual resistors like 10 and 10. Remember, the current split in it's split in two parts there. So, and two parts equally, which is quite simple. Now let's go to question 2.2, which I think is even more difficult because it is sometimes very difficult to understand and explain this one. Now the switch S is open. So what happened here? Where is switch S, guys? Let's click quickly there. No, it is here. Switch S is right here at the bottom. You can see there. So we have this switch. Now, if that switch is open, then the circuit, what is going to happen to the circuit? All this part will not be there anymore. All that will not work anymore because the current cannot flow that side. So we only have that part top. So if you take off a resistor that was here in parallel, then the resistance of the circuit increases now. Okay, but now let's see what does the question say. How will the reading of the ammeter A1 be affected? So how the current affected and how the reading of the voltmeter V1 will be affected. V1 is the voltmeter here. That voltmeter is reading the external potential difference. So how the current is going to be affected. Okay, so let's see what we have to say here. Question 2.3.1. Okay, so the first thing we're going to say is that the EMF is constant. Remember, the EMF only depends on the battery. So the EMF here is going to be constant. Okay, now the total resistance is going to increase. Is going to increase as you remove one resistor connected in parallel. Remember, it is in the lesson of resistors connected in parallel. So what happened to the current? If we go to the formula, EMF is equal to current multiplied by R external plus R internal. All this one here is R external or R total. Okay, so if we rearrange this one, we have that EMF is equal to current multiplied by total resistance. Okay, if you rearrange in terms of current, you can see that current is equal to EMF divided by total resistance, which is inversely proportional. Therefore, if the total resistance increases, then the current is going to decrease. That is the answer for that question there. Total current decreases there. Next question, how will the reading of the voltmeter V1 be affected? Now V1 is reading the external potential difference, okay? So what we are going to say here for question 2.3.2. First, EMF is constant. Internal resistance is also constant. You cannot change the internal resistance. To change the internal resistance, you must change the battery. Okay, now the total current, which is the same, decreases. Total current decreases. So what is going on here? Let's see to the formula. EMF is equal to potential difference external, right, plus current multiplied by internal resistance. Let's go to this formula, and this one is the one that is going to help us. If we rearrange this one, we have that B external is equal to EMF, which is constant. It is the same as before we open the switch, minus current multiplied by the internal resistance, which is also going to be constant. Now, what did happen to the current? What did happen to the current here? The current is smaller. So the EMF, which is the same number as before, is going to be subtracted by a number that is smaller than before. Therefore, the V external is greater than. So the V external is going to increase. Is going to increase. Guys, this is the end of the video and the end of the question. It's a very challenging question. I hope you understand. It's a very good question. Thank you for watching. Thumb up, subscribe for the channel. I'll see you next time. Mr. G here.